Hello learners, and welcome to today's lesson of functions and relationships, equivalent forms. Now we are going to focus on the practice and application questions. Let's go on to those practice questions. Our first question there says, fill in the following flow diagram and write the formula or write down the formula for this flow diagram. So we are going to look at this flow diagram, and we know that our flow diagram starts with our input values. So we know that we start with our input values. And our input values are going to result in our output values, of course. So what input values have we been given there? We have been given a 4, a 6, and a 9. And in the middle of our flow diagram, we have been given that rule that we are supposed to apply. So whatever is there, we need to apply it to the input value in order for us to get that output value as a result. Remember, the output value is a result from using our input value. So let's see how we can get those output values from the given rule. So using 4 as our first input value, we are going to multiply that 4 by 8. And when we say 4 multiplied by 8, what is the answer? If you have 32, then you are correct. What about the next input value there? Now we have been given 6 as an input value. So what do we get when we say 6 multiplied by 8? Yes, we get an answer of 48. And that last input value there, we have 9 multiplied by 8. Yes, that is going to give us a 72. So that is our 9 multiplied by our 8. So from our input values, we were able to get our output values. Now we need to write down a formula for this flow diagram. Remember, a formula is the rule represented using symbols. So we are going to represent our flow diagram using those symbols. So we know that the output value was obtained by taking the input value and multiplying it by 8. And that is our formula right there. So just to write it in a simpler way, we can say that our output value, which is the y, is obtained by taking the 8 and multiplying it with the input value. So y is equals to x, and that is our formula for this flow diagram. Let's move on to the next question. So in the next question, we have been given another flow diagram, and we need to firstly fill out that flow diagram, and then after that we are going to write an equation for this flow diagram. Now if you notice, our flow diagram has 2 parts to it. That means that our input value is going to go through one part of the rule and then again through a second part of the rule for us to get our output values. We know that those input values are represented by x and those output values are represented by our y. So our first input value there is the 1. So we are going to say 1 multiplied by 3. That, of course, will give us a 3. And from that 3, we are going to add 5, and that is going to give us an 8 as the answer. So 1 multiplied by 3 plus 5 gives us an output value of 8. What about the next input value? So we have there a 7 multiplied by 3. Now 7 multiplied by 3 is 21. 7 multiplied by 3 is 21. From that 21, when we add a 5, then we get an answer of a 26. Then we have 15 multiplied by 3. Of course, 15 multiplied by 3 is 45. But when we add 5 to that 45, that is going to give us an output value of a 50. Now, how can we write down the formula for this flow diagram? Well, we know that we are looking for the output values, and how exactly did we find these output values? Well, we took the input value, we multiplied it by 3, and we added that 5. And of course, we know that x multiplied by 3 is 3x. And then we added our 5. And that's how we have calculated, or that's how we have found the formula of this flow diagram from using symbols. Let's go on to the next question. Now it says there, complete the table below and write down the equation to represent these input values and output values. Now in our table, we have been given some input values and only some of the output values have been given to us. Now we are supposed to use these input and output values to fill out the rest of the table. Or to fill in the rest of the table, we are going to say, or we are going to look at what relationship exists between the input values and the output values. That way we can fill in the rest of the table. So we are going to say 1 was the input value, and we can see that 3 was the output value. Then when 2 was the input value, we can see that 7 was the output value. And when 3 was the input value, 11 was the output value. Now, because these input values were consecutive numbers, that means that actually these first 3 output values are forming a pattern. And do we remember how to find the rule when we are working with number patterns? Well, let's use that knowledge to find the next terms, or to fill out the other output values here. We can see that from the 3 to the 7, because they are consecutive, now this means that there can be a constant difference or a constant ratio between them. So between the 3 and the 7, there is a 4 that was added. And again, the next one, which is the 11, is also part of those consecutive numbers. We can see that from the 7 to the 11, we just added that 4. So what can we conclude here? We can conclude that if we need to get to the 4th value, or where 4 was the input value, we can get to that output value by just adding a 4, because as we can see, they are still those consecutive terms. So when we add 4 to 11, that is going to give us a 15. And again, the next input is a 5, which is consecutive because after 4, it is 5 on our number line. So we are going to again add 4 to our 15, and that is going to give us a 19. Now looking at the next one there, the next input value is a 10. Can we simply just add 4 to get to that output value when the input value is 10? Absolutely not. Remember, we are talking about consecutive numbers. So we cannot simply add a 4, because after 5, we do not get a 10 on our number line, but after 5 is a 6 on our number line. So now that means for us to know what happened when we inserted an input value of 10, for us to know what the result was, we need to find the equation or the algebraic rule to these numbers. Fortunately for us, the first 5 numbers are in a pattern or are consecutive. So that means we can simply use our knowledge from number patterns to find the rule here. So let's look. When we want to find the output value, we know that we are going to take that 4 that is being added, which is now our constant difference. So we are going to take that 4. We know that that is going to be multiplied by our input value, and we are going to add a constant value to find this rule. So we can take, of course, any input or any output. Let's take the third or the input of 3. Now the input of 3 gave us an answer of 11. The input of 3 gave us an answer of 11. We know that we took 4, we multiplied it with the input value of 3. That's how we got the answer of 11. But Obviously, 4 multiplied by 3 is not 11. We still have to add or subtract that constant. So 4 multiplied by 3 is 12. And how do we get to the 11? We are going to subtract that 1. Let's check with another input and output value to see if we are correct. We can go and take the input value of 5, which gave us an output value of 19. So we know that we are going to take 4, which is our constant difference there. We're going to multiply it with the input value of 5. And we are going to see what constant we need to add or subtract to get to that 19. So 4 multiplied by 5 is 20. And how do we get to 19 from 20? Yes, we are going to subtract 1. So what does this mean? This means that our equation or our algebraic rule is y is equals to, so for us to get the output value, we're going to multiply the input value by 4 and we are going to subtract 1. So it means that our rule here is y is equals to 4x minus 1. Now, why did we find this rule? It's because we wanted to know that with an input value of 10 and an input value of 20, what is the output value going to be? So we can quickly calculate those output values. So remember, we are going to multiply our input value by 10 and then we are going to subtract 1. So that is going to give us, if we say 4 multiplied by 10, that is 40, and that is going to give us, after we subtract 1, a 39. So that output value there is 39. Then again, we're going to do the same thing for the input value of 20. We're going to say 4 multiplied by 20 minus 1. And what answer do you get from there? You are correct if you got an answer of 79. So those are the values that were missing in our table. And of course, we could find some of them by noticing a pattern within those consecutive input values, and that helped us to get some of the output values in our table. And when that also helped us to get the rule for these numbers, and then we could fill out the rest of the table. Let's look at our last practice question there. It says, find the rule to this flow diagram in algebraic form. Now, firstly, we can see that our rule, it does have 2 parts to it, but one of the parts is not given to us. So we need to first find the missing part of that rule, then we can write that rule in algebraic form. Now remember, when we already have our output values, all we need to do is to use our additive inverse and multiplicative inverse for us to get to the input. And since as well we have the input, we are only going to use the additive inverse of that minus 4. We can see that the last part of our flow diagram is the minus 4. What is the additive inverse of this minus 4? Yes, it is to add 4. So from the output value, the first output value there is an 8. So from 8, we are going to add 4. That is going to give us a 12. And then we need to see how we moved from 4 to 12. Now, there are 2 options here, but remember, the option that we choose has to work for all of the input values. So we can either say that we added 8, or we can say that we multiplied by 3. Let's see which option works for the rest of the input values. So from 20, which is the second output value, we are going to go back using the additive inverse and we are going to add our 4. Now 20 plus 4 gives us a 24. Now from 8, how are we going to get to 24? Is it by adding 8 or is it by multiplying by 3? Of course, it is by multiplying by 3. So that means we are going to use that first part of our rule as a multiply by 3, because 8 multiplied by 3 does give us 24, and then when we subtract 4 from that, we will get 20. But just to be extra sure, we need to make sure that it works also for our last part or our last input value. So when we take 10 and we multiply by 3, we know that gives us a 30. And when we subtract 4 from that 30, indeed, we do get our 26. So that means that the missing part of that rule was to multiply by 4. Now let's write that rule in an algebraic form. That is going to be the output value we get from multiplying the input value by 3 and subtracting 4. So that means that our algebraic rule is going to be 3x minus our 4. Let's quickly go to an ad break and then we'll see you just now.